In this lesson, we are looking at how to use partial fractions to decompose rational expressions. And to understand where this is coming from, we're going to start by doing this review problem. So I have 2 over x plus 1 over x plus 1. If I'm told to add this, the first thing I'll do is to find the LCD, and the LCD here is going to be x plus 1. So now I'm going to make sure I multiply each of these by I know the by whatever is missing in the denominator. So this is x plus 1, and for the first one I can see the denominator is missing x plus 1, so I'll multiply the top by x plus 1. And I also see that for the next denominator 1, it's missing x. So I'm going to multiply 1 times x. And when I do that, I can simplify. So I get 2x plus 2 plus x over x plus 1. And this simplifies to 3x plus 2 over x plus 1. So you can see this fraction here, the one I was given at the beginning, simplifies to that fraction. So we went and added, and when we do partial decomposition, as you can see at the bottom there, it is starting with the simplest simplified answer and taking it apart or decomposing it. So we're going to be working backwards. This is what we call decomposition. So we are going to be working backwards. Now let's do an example here. We have 3 cases we are going to be looking at. In this lesson, we're going to look at case 1. So if I have this fraction, my first step in this fraction is to look at the denominator and factor it. I'm going to factor the denominator. And what does the denominator factor to? The denominator factors to x. So I have x squared. I'm going to write it here. X squared plus x is the same as factoring whatever is common. So x is common, and then x plus 1. See, I'm breaking it down. So when I break it down, now I can go back here. So I know what the denominator is. And my second step is to write the original equation. So this is 3x plus 2 over x squared plus x. And check what I'm going to do here. See, I want to decompose this into simpler fractions. So how do I do that? I'm going to introduce letters a and b because I do not know what the denominator is, but I know the denominator is x, and I know the other one is x plus 1. And where did I get this from? From factoring. From the factor. So from factoring, so I came over there. Now my next step is to do the right hand side. So, and in the right hand side, I'm going to simplify that fraction. So I have a over x plus b over x plus 1. So remember the denominator is x plus 1, x plus 1, and then so the first one is missing x plus 1, so I'm going to write a x plus 1. Then I'm going to write b. The denominator b is missing x, so I'm going to multiply that by x, and what do I get? What I have here now is ax plus a plus bx over x plus 1. So this is x plus 1. So now check what I'm going to do now. I'm going to take the original fraction and write it here. So 3x plus 2 over, see, this is x squared plus x, or just x plus 1. It's the same thing. And what I'm going to do in the next step, I'm going to go back to, I'll write over here because I have more space here. 3x plus 2. Here I'm just rewriting the same thing. X is equals to, I'm going to combine the x, the ax and bx together because both of them have x, plus a over x plus 1. See, the denominator is the same. And then I'm going to go one more step. I'm going to take the denominator, I'm going to factor the x out. So x a plus b plus a over x plus 1. And since we can see that if you look at these two equations, you can see the denominator is the same. So it means I can equate the numerators. So I'm going to say 3x plus 2 is equals to a plus b, a plus b and the x is there, plus a, and then having this side by side, I can be able to see that this 3 corresponds with a plus b. So I can write an equation here and say a plus b is equals to 3, and I can equate a to 2. So I'm going to write here a is equals to 2, and if a is equals to 2, I can see b must equal 1. So those are the values of a and b. So if I went back to the original equation, I could come back here and replace a and b, and I could actually write, if I use my eraser, I could write a is equals to 1, and I could write b is equals to, no, sorry, a is equals to 2, so I'm going to erase that. So a is equals to 2 and b is equals to 1. That's how the fraction is going to be. Here is another example we can do, and here same process. So I'm going to take, I start by factoring the denominator. So the factor denominator is going to be x minus 4. Two numbers I can multiply to get negative 12. When I add them, I get negative 1. So an x plus 3. So now I'm going to write my equation. So this is 5x plus 1 over x squared minus x minus 12 is equals to my denominator. Remember, I'm now going to use a over x minus 4, and if you did x plus 3 first, it doesn't matter, and then b x minus 3, and then my next step, I'm going to write it out here. So remember, the common denominator, or the LCD, is just my denominator here, and x minus x plus 3. This is x plus 3. Now my next step, let me do the top. So the first one is missing x minus 3, so I'm going to write a x minus 3 plus the second one. What is it missing? It's missing x plus 3. Why do I keep writing x minus 3? So this is going to be x. So the second one is going to be x minus 4. Okay, now I move over here, and what does this become? So I'm going to distribute this side, the top. So I have a, and maybe I need to move it a little bit on this side. So this is this step I brought over here. So this is going to be a x plus 3a ax plus 3a plus bx minus 4b, and I'm not even going to write the denominator anymore here because I know I'm just equating the numerator. So this is equal to 5x plus 1, and what I'm going to do in this step, I'm going to combine the like terms. Ax plus bx is plus 3a minus 4b. Then I'm going to combine the like terms. A plus b. Actually, I already did that. I'm just factoring the x out. Plus 3a minus 4b. And all this is equal to 5x plus 1. Then what am I going to do? I'm going to equate the like terms. If this equal that, so what does that mean? It means a plus b is equals to 5. And what else do I have? See, all this is going to equal 1. So I'm just going to write here 3a minus 4b is equals to 1. So what do I have here? Oh, I have a system of equations. So a system of equations, so I'm going to solve this system of equation. So I put a line there. I'm going to multiply everything on top by 3. So I get 3a plus 3b is equals to 15, and then 3a minus 4b is equals to 1. See the a, I can now eliminate a because those are equal, so I'm going to subtract. So I get a is gone, and then I have 3a minus negative 4, 7b is equals to 14. So that means b is equals to 2. And if b is equals to 2, then if I come back to one of my equations said in one of my equations I have a plus b is equals to 5. So remember here we said b was 2. So that means a is equals to 3. A is equals to 3. So I got my a and b right there. So now my final answer, I can actually write it over here. I can write 5x plus 1 over x squared minus x minus 12 is equals to a, which is 3 over x minus 4 plus b, which is 2 over x plus 3. And that's going to be the final answer. So it's just many steps, but if you just pay attention, you will be able to follow through.